Hey, what is up? Today we are going to learn a little bit about Spring Cloud Stream, which is a framework built off of the Spring framework that allows us to build highly scalable event-driven microservices. We will be doing this using Spring Boot 3, RabbitMQ, and also Postgres as our database. Now there's going to be three main components for Spring Cloud Stream, which is the source that is the initial starting point where we will be getting data from, and then there's going to be the processor, which will transform or aggregate, filter the data, and then finally we have our consumer, which is the final destination of where the data will go. Now we can build these custom streams and then we can attach it to a tool like Spring Cloud Dataflow, and here's kind of like a data diagram of Spring Cloud Dataflow, and we're going to be building this piece with the source processor and sink here. Okay, so the tools you're going to need is RabbitMQ and Postgres. For the RabbitMQ part, if you want to install it directly on your computer, you are going to need Erlang setup, and if you go to this link, which I will post in the description, you can see which version of Erlang you need, which is currently 26 or 25, and then you can install the version tree for it, depending on if your computer is 64-bit or 32. And once you get that installed, then you can run the RabbitMQ setup. Alright, so go ahead and get those things set up and then we will get into it. Today we are going to build a simple stream involving Pokemon. So what we're going to do is we're going to, let's say metaphorically we captured a Pokemon and then we want to either send it to the daycare or we want to send it to our Pokebox, depending on the total power of the Pokemon. So this is going to follow that pattern I mentioned earlier where we have a source, processor, and consumer. So we're initially going to capture the Pokemon, send a REST request, and then we're going to process to see if the power of that Pokemon meets a certain specification, and if it does, we'll send it to the consumer to put that Pokemon either in the daycare or in the box. Now, this is quite a simple idea, but it's just going to give us kind of an idea how to use Spring Cloud Stream. Another idea that I was thinking about, but we're probably not going to do, but let's say if you are an owner of a trading card shop and you receive trading cards from other people who are trying to get rid of their cards. And so initially when they send you their cards, you'll get a REST request sent of the card's details and the card, like what the card is, its rarity. Yeah, the customers will also be sending you the current condition of the card. So if it's in bad condition, you'd probably want to just put it in your shop. But the idea would be that, a consumer or clients could send you an initial REST request, and then with those details, you can process it. In the processor, we would look at like the rarity of the card, the condition of the card, and all that. And then based off those conditions, we would either just, if it's in bad condition, we'd probably just put it up on the shop. But let's say if we found a rare card in good condition, we'd probably want to send it to PSA to do more grading on it, so we could probably sell it for a higher price. So that's another example of how you could use Spring Cloud Stream. And the nice thing about this is once you build these things, you can also use them on Spring Cloud Dataflow. All right, so let's go ahead and get into it and start building out our Pokemon daycare processor. All right, I'll see you there. The first thing we are going to want to do is open start.spring.io, and we're going to select the latest stable version, and I'm going to do this in Gradle, and I'm going to go ahead and fill out these details here. The demo is going to be Pokemon source demo, Pokemon source demo project for Spring Boot source example. And we're going to do this in Java 17. Okay, so we're going to go ahead and add a few common dependencies that we're going to use on all of the source, the processor, and the consumer. Some of these things you might not need, but we're just going to go ahead and add them. So the first one is actuator. Second one, we're going to do JPA for Postgres, and then web, and then Spring Cloud Stream, obviously. So Cloud Stream, and then we also want to add RabbitMQ. We're going to do Spring for RabbitMQ, and then we also want to do Postgres. Let me just make sure we got everything. Another one we want to add is Lombok. And then we can click this explore button to ensure we got everything we need. So actuator, AMQP, JPA, web, stream, binder, rabbit, Lombok, and Postgres. I'm going to be adding 2 other libraries after we get set up, but basically these are the starting point dependencies we're going to be using. All right, so go ahead and generate this project and make sure we're going to save it in a location where we're going to work on in the future. But before I do that, I'm going to create the other project. So processor. So processor example. And everything should be the same here. So go ahead and generate that. And then we're also going to create the consumer. Okay. Consumer example. And then we're going to go ahead and generate that as well. Okay, so what you're going to want to do is, let's open our File Explorer, and I'm going to get everything I downloaded and save it in a location that I will be using in the future. Here, Spring. I'm going to go ahead and put it in here, and then I'm going to extract the data. So I'm going to grab this, Control X, post it in here. Source, processor, and also the consumer. All right, and then I'm just going to delete these zip files because we don't really need them anymore. Now that we have the initial project set up, I'm going to go ahead and open it up on my IntelliJ. So I'm going to go to File, New Project from Existing Sources, and I'm going to go ahead and locate the file location. So that's going to be in my Documents. Let's go to Videos, Spring, Source Code. So I'm going to import the source first. Just open this up, make sure we got the Gradle build. Okay. Select Gradle, create, trust this project, new window. And I'm going to import the rest of the services. So new module from existing sources. We're going to select the processor, Gradle, create, and then another one, new module from existing sources, and consumer. Okay, so now we got all three of these in here. I'm going to start on the source one, and then we're going to work our way source, then processor, and then finally the consumer. So the first thing you want to do is go into the build.gradle file, and I am going to add a few more libraries that are going to be able to help us with our project. So first I'm going to go to this ext part, and we're going to set some more libraries up. So set Spring, and let me zoom in here so we can see. Spring Open API Web MVC version, and that's going to be 2.6.0. And then also another one we're going to use is Apache Common. In that version, we're going to be using 3.14.0. Okay, and then I'm just going to go ahead and add them in here. So, implementation. It's double quotes for this one, org dot spring doc spring doc slash open API slash starter web MVC GUI, and then we're going to put in that version we set up above. Okay, and then I'm also going to add the Apache library implementation org.apache.commons commons-lang 3, and we are going to import this here. All right, and then we can do that to bring them in. So I know I typed these out, but you can also find them online. So if you go to like Maven repo, come on. Why is it, no, Maven repository. You can find them here. You can just search like Apache common, and there should be lang 3 somewhere here. Lang 3. Yep, right here, Apache Commons. And then also we're using the Spring doc open API. Spring doc open API here. And they will show you how to set that up. But we'll also set it up on this project, so you don't need to worry about it too much. All right, so before we get started, I'm also just going to copy these extra libraries to the consumer as well, just so we have them. So go into Pokemon Consumer, and then the build Gradle, let's just go ahead and add them in while we're here, so don't forget. Go to this build Gradle and just add that in here as well. Go ahead and save that. Now what I want to do is let's set up the resources we're going to need, the application resources. So let's go into main, source main, and then we can get rid of these two here. And we can just rename this one application.yaml. Okay. So let's see here. That should work. And then we want to set the port server, port, and then I'm just going to use 9002. And then we're going to be using Postgres for our database, so I'm just going to set up that connection here. So Spring data source URL JDBC Postgres QL Postgres QL, that looks right. Localhost, and then we're going to create a we are going to create the database. So captured Pokemon, and then demo. We'll just call it captured Pokemon DB, and then the username. So I'm going to add some environment variables, but we're also going to set some default values. So if you have different ones, you might want to change it depending on what you set your Postgres to. So Postgres username, and then the default is just going to be Postgres, and then the password, Postgres password. That is also going to be Postgres. Okay, so the next thing I'm going to do is have JPA auto-generate some of our tables that we from the entities we're going to be making. So generate DDL true, and then we're just going to set show SQL to false for now. All right. So I think that should be fine. One other thing I want to set up is let's set up the RabbitMQ as well. So RabbitMQ. So for Spring Cloud Stream, you usually don't have to if you're using default stuff, but it's good to set this up. So host name, we're just going to use localhost, and then the port is RMQ port 5672, and the username RMQ username, and for the local host, it's just going to be guest. Password RMQ password guest. All right. So that should be good enough for our initial setup. Okay, so I'm going to go ahead and try and test this out to see if we can get it to run with these properties. So I'm going to go to the application and click on this run button here. See if we get any issues. Okay, so it looks like we got an exception, unable to create request service, JDBC environment, unable to determine dialect without JDBC metadata. Okay, so this is common. Sometimes you might need to set the dialect, but this is happening because we forgot to create the actual database inside of Postgres. So what I want you to do is copy this database name, and then we're going to go into pg admin. So let me just close this and open it up. pg admin, get Postgres started up. And so whatever you set up for your Postgres, you want to put it inside the username password here. Once you get Postgres opened, it should look like this. We're going to click on the server area, and it's going to request for the password, so that should be Postgres. And you can see I did a little bit of demo here, so I'm going to go ahead and right click on this database and then create the database. We're going to paste that name we created. So captured Pokemon DB. Owner is Postgres. Go ahead and save that. So once you have that, let's go back to our project and try and rerun it again. So I'm going to go back to the application and then run it again. Let's see if it will start up successfully this time. All right, so it looks like we have a successful startup. Now we can get to work. I am going to create a few packages here, and this is where we are going to place our code. So the first one's going to be the controller, and then create another package called the DTO, another one for entity, and another package event, gateway, repository, and the last one is going to be the service. Okay, so we got the packages created. I'm going to go into the controller and create our first class, which is going to be the Pokemon controller. Okay. All right. So we're going to go ahead and create the controller. What I also like to do is just create the entity as well. So I'm just going to go into here, create another Java class and call it Pokemon. And we're going to add a few details. Let's add some Lombok annotations. So no args constructor, let's add a getter, setter, basically creating a POJO. And we're going to mark this as an entity because we're going to persist it to the database, and we're going to give it a table. The table name, we're going to name it to Pokemon captured. All right. So as with most tables, we want to set up a initial ID, column name, column, we're going to make it not nullable, and then we're going to automatically generate the values for these IDs. Generation type, identity, private long ID. And what I'm going to do is just copy this the CSV I got offline, and I'm going to be posting it in the GitHub page. But we're just going to be using the properties that we find inside of this CSV. So another thing that we could have done with Spring Cloud Stream is we could have had our source as like taken in CSV files. But for this example, I'm just going to use a REST request. But I'm going to get these properties here, and I'm going to put them into our entity. So we're going to go private string name, private string type 1, private string type 2, private integer total. And this total part is basically what we're going to be using in the processor to determine if we're sending it to the daycare or not. HP. integer speed nations boolean dairy private boolean processing status and private string its ID. Okay, so you could also add some other variables in here, but I'm just going to keep it simple. Other variables that you might want to add is maybe like a nickname, or also like the sex type, is it male or female? You could add other variables in here. But I'm going to go ahead and save this and then rerun the application. And what this should do is it should create a new table inside of the Postgres database. Let's see if that happens. So it looks like we started the application. If I go to Postgres, let's look at the Capture Pokemon DB schemas and tables. We got a new table here for Capture Pokemon, and I should have all those variables we set. So let's see, run a select, and there we go. Yeah, so we got the ID, the attack, defense, everything we added, created. So looks good. Okay, so we got the entity created and it's showing up in our database. I'm going to go back into the controller here and we're going to start creating that REST endpoint where we will be accepting these requests and we are going to process them. I'm going to use the all-args constructor so we don't have to do like the Spring Boot auto wiring stuff. Yeah. REST mapping, request mapping. We're going to just set this to Pokemon. And I'm going to be using the Swagger annotations. Name. Controller. Okay, so basically this controller will only have one endpoint, which is a post for captured Pokemon. So I'm going to create that real quick. So public response entity, and it's going to just return a string value, captured Pokemon request, and in the request body, I'm going to create a DTO for Pokemon request. We're not going to have it yet. And we're going to create those pretty soon here. I'm just going to add this annotation for request mapping, or not request mapping, post mapping. And I'm going to set this to captured. Import this request body from Spring Framework. And we're also going to use a service, so private Pokemon service, Pokemon service. All right, so I am going to create the DTO first. So if we hover over this, we should be able to see create Pokemon class. I think if I press Alt Enter, we'll get all these other options. So I'm going to create the class, and I'm going to put it in the DTO. And let's go into that DTO spot. So Pokemon request here. And we're going to add some annotations. So getter, setter, and then also the builder. Pokemon request at non-null, private, string name, non-null, private, string type 1. So these variables are pretty much going to be the same as our entity. So if we go side by side here, they're pretty much going to be the same. I'm just going to copy them just to make it easier. We just want to check some stuff to make sure it's not null, just for demo purposes. Okay, and then I should be able to just copy the rest of them. So yeah, the main difference is we don't have this processing status in the reference ID. That's because we're going to be using these two in our stream to track the status. Okay, so I'm going to go ahead and close that. Save this, go back to our controller. We need the service as well, so I'm going to go ahead and Alt Enter. Let's create a class. Usually I like to set up my services as an interface and then have implementations of those services. But I'm just going to make a simple service for now. So we create a new service here. Let's go down here. Okay, we got the service. And we are going to get that all set up. So at service, and then all args constructor, and then SLF for J for logging. Yeah. Inside of our service, we're gonna have a private Pokemon captured repository. And I'm gonna go ahead and create that repository as well. So Alt Enter, create the class repository. And this is actually supposed to be an interface, so interface, let me make sure that's good. And it extends JPA repository. The type is going to be the Pokemon, and we're going to have a long ID. Should be good. Okay, we also want to annotate this with the at repository, and I'm going to add a custom query using JPA repository. So we're going to get a list of Pokemon, and we're going to find the Pokemon by processing status, and we want to find the Pokemon that haven't been processed yet or haven't been sent to like our box or daycare yet. Processing, and we're going to import this list. Okay, so that looks good. Now we're going to build upon our service and controller. Should be getting less errors now, so I'm going to go back to the controller, and we're just going to add a few open API swagger stuff. So description, handles, captured Pokemon, and places them in the Pokebox or Pokemon daycare. period. I'm also going to add an API responses with a S. Give it some values. I'm going to add the first one, API response code of 500, and the description, internal server error, and another one, API response code 200, description, just do success. All right. So we got that all set up. The next thing we're going to do is fulfill this request. All right. So when we get this new Pokemon request, we are going to validate it first. You can also do this in your service. I like to keep my controllers pretty clean, but for this example, I'll just Apache Commons. We'll just do some validation here. I'm just going to check for empty values. So we're going to do Pokemon request get name, and we want to check if they're empty or not. What the heck? String utils dot is empty. Get type. And also one last one, which is Pokemon request get total. We want to make sure the total is greater than 0. All right. So should be everything. Let's create some curly brackets here. And if we get any of these, we want to return a bad request. So response, entity, bad request, and build that to send it back to the requester. If everything is good, then we are going to save this into our database. So optional, Java util optional, okay. And we're going to get a string back to Pokemon reference ID equals, and we're going to go into the Pokemon service and we're going to create a new method, save captured Pokemon request, and I am going to want to create this method here. So we can either go over it with our mouse and it might ask us, or I should press Alt Enter, and we can create the method here. So we're going to create that method. I'm going to leave it for now and come back to it later. Finish out this controller first. So we're going to return Pokemon reference ID, and then we're going to map the Pokemon reference ID, and we are going to get a response spelled it wrong. Response entity dot status and HTTP status created, and then add to the body. So this is the string we're returning back to the user. Your Pokemon reference number is plus Pokemon reference ID, and or else if we don't get anything, we are going to do a response entity status of HTTP status internal server error dot build. Okay, so should be good enough. Let's see here. Just clean this up a little bit. Okay, that looks good. So the next thing we want to go into is our Pokemon service here. And we are going to fill out how this captured Pokemon is going to be done. I'm gonna wrap everything we're gonna be doing in a try catch. We're gonna catch any exceptions. And we're gonna log them first. Exception.getMessage. And we're gonna return an optional of empty. Okay, if everything goes good, should be creating a new Pokemon in that database table. So new Pokemon, and we're going to use the bean utils to just copy everything from the Pokemon request to the new Pokemon. So copy properties. So we got the Pokemon request, and we're going to copy it to that new Pokemon. And then we're going to set Pokemon.set processing status to false, so it hasn't been processed yet. And then we're going to create a random reference ID. So set reference ID, and that's going to be random string utils random. I'm going to make it 10 digits long. We're going to use letters. We're also going to use numbers. Okay, and then we are going to save this Pokemon into our table. Pokemon saved equals Pokemon captured repository, save that Pokemon, and we're going to return it back. We're going to return that reference ID back. So Pokemon saved dot get reference ID. All right. So that looks good. I'm going to go ahead and save all of this and then just rebuild the project so we can test it out. All right. All right. So project started up successfully. I'm going to open a new browser, localhost 9002, and then the Swagger default page should be swaggerui.html. All right, so it looks like we were able to create that endpoint successfully, and I'm going to test it out, try to add a new Pokemon. Basically, you could just put whatever you want in here, but I'm going to use that CSV, and I'm going to just do the first entry for Bulbasaur. Kind of have one of the JSON values saved here. You can put whatever Pokemon you want. Yeah, let's just make sure everything matches up here. So we got total 318, yep. Everything looks good. And I'm going to go ahead and execute this request. All right, so it looks like the response was successful. We got a 201. Okay, might need to change that in the future. The reference number is optional. That doesn't look right. Let me see if I can, if that is right. Let's see. Um, do 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 do. Should be right. Reference number. Oh, it's supposed to be this. Okay. So I'm gonna go ahead, save this, and restart. And then we're gonna just make a request again. Same Pokemon. Go ahead, execute it, and yeah, your Pokemon reference number is that. And if I look at the Postgres to confirm this, so we got the select method running on our captured Pokemon. Run this, and we got 2 entries for Bulbasaur here. We can see the processing status is false, and that's what we're going to be working on next. This is where Spring Cloud Stream comes into play. We're going to look at all the Pokemon that haven't been processed yet, so everything that's false, we're going to capture all those falses and we're going to run them down the stream to either send them to the daycare or to our Pokebox. Okay, so first thing we are going to do is just create some events. Since this is event driven microservice, the first event I'm going to do is new Pokemon event. I'm also going to create another one that holds the Pokemon details. So let's see, new Pokemon event. It's actually going to be a record, and it's going to hold a list of Pokemon details. Pokemon detail list, and we want to import that. Yep, looks good. And then inside the Pokemon detail is pretty much going to be the same as our other entities. So we could probably just, reference our entity here. So I'm just going to split this to the right and add a getter, add a setter, add a builder, no args constructor, and an all args constructor. Might want to add these because Spring Cloud Stream definitely has some issues with object types. But yeah, I'm going to copy all of this stuff, except we don't need the processing status. So we need everything except the processing status. So let's delete that. We're going to carry the reference ID so trainers will know if their Pokemon made it to the Pokebox or the daycare based off the reference ID. All right, so we got all the events set up, new Pokemon event, and we also got the Pokemon details for each event. Now, what we need to do is create a gateway, and this gateway is where we're gonna be doing all of the whole stream. So I'm gonna call this Pokemon event publisher, and we're gonna add some logs just in case we need to. Add an all args constructor, and we're gonna do a configuration. Okay, so we're also going to create a new service. So Pokemon event publisher service. We will create that right now. So Alt Enter, create the class inside of our service. And we will work on this service later. For now, I'm going to go back to the gateway, and we are going to create basically our bean for the stream supplier. So public supplier, and you want to make sure it's a Java util function here. New Pokemon event, so that new event we created, and we're going to publish new Pokemon event. So whatever you name this method, you want to keep tabs of it because we're going to set it up in our application YAML, which we will do near the end here. So I'm going to return a function of optional new Pokemon event. And we're going to use that new service we're going to set up, and we're going to publish a new event. And then after that, we will return new Pokemon event that we get from that service, or else we're just going to return null. Okay, that looks good. I'm going to go ahead and create this new method here inside our Pokemon event publisher service. So this is going to be a bit long, but what I would like to do is we need the repository as well. So private, and we're going to add some annotations here, SLF for J. I'm also going to add the all args constructor, so we don't have to do that auto-wired annotation for Spring. Pokemon captured repository, and we got this optional new Pokemon event. All right, so what we're going to do is we're going to get the list of Pokemon that haven't been processed yet, and we're going to find them so we can send them off for processing. So list Pokemon list, import that, import the list, equals Pokemon captured repository dot find by status. So if they haven't been processed, they have that processing set to false, which we can see here, processing status of false. Next thing we want to do is put that in our Pokemon details Pojo created. Pokemon details equals Pokemon list dot stream map Pokemon inside of there. We're going to use our bean utils to just copy it again. Bean utils, copy properties, Pokemon detail. Oh, forgot to create a detail. So Pokemon detail equals Pokemon detail builder. Okay, we're just going to copy whatever we get out of this request, this list of Pokemon, we're just going to copy it to the Pokemon detail. And then we're going to set the processing status to true. Pokemon set processing status true. And then we're going to return the Pokemon detail. And we need to set this to list. So that'll give us the Pokemon details, which we are going to add to our event. Now what I want to do is, just so we can see what's happening, we're gonna see how this streaming kind of works. And what it does is it just constantly checking the database. So what's happening is it's going to be running this request multiple times, being like, has there anything changed? Are there new Pokemon to process? And that's basically what the source does. It's just constantly checking to see if something's changed. All right, for new Pokemon requests, available records process. Let's see here, Pokemon list signs, okay. Optional. I create a new Pokemon event. To publish equals empty optional. We're going to start out with something empty. And if the Pokemon details is not empty, then we're going to send it off downstream to our processor to determine if it needs to go to the Poke Center, or I mean the Pokemon Daycare or the Pokemon Box. Updating Pokemon status as processed. Some of that so we can see what's happening. New Pokemon event. We're going to create a new Pokemon event, and we're going to add the Pokemon details inside of there. I'm going to set this to new. And then in the Pokemon captured repository, we want to save everything. So Pokemon list. So right here we were setting the process to true. So we want to save that into our database. And then we're going to return event to publish. Okay. So yeah, basically we're gonna, if we find new Pokemon that haven't been processed yet, we're gonna put them in the details list, and then we're gonna create a new Pokemon event, and we want to make sure the event to publish here is populated so it's not empty. Optional of, and then the new Pokemon event. So what's going to happen is the publisher is going to be constantly running this request, and we'll see that happening, and it'll be checking the database to see if there's any statuses that it can process. Before we can actually have that happen and have it send it off to RabbitMQ, we need to update the application YAML. So what you want to do is you want to make sure you copy this method, because we are going to be using it inside of our properties. So right under JPA, we're going to add another one. So cloud, stream, bindings, and then we're going to paste that, and we're going to send it out. So like as described in the picture, we got the source, we're going to send it out so our processor can pick it up. Out -0, and then destination Pokemon processing, and this is going to be the exchange name. And so Spring Boot's going to be creating these exchanges and queues for us in the background. So that's kind of nice. So we're going to group this in homing Pokemon. So throughout this Pokemon, the setup, we will be using the homing Pokemon group. So I'm going to go ahead and save all. I think that's everything we have set up. Let's go ahead and test it out. So what I want to do is also open up my RabbitMQ. So at localhost, yep, gonna make sure we got RabbitMQ. Okay. So we got a lot of exchanges set up, but we're gonna have a new exchange set up for Pokemon processing, right? And yeah, so I'm gonna go ahead and run this. And it's gonna happen so fast that we probably might not even see the messages. But yeah, so you can see right here, it found 2 available records to process. And it processed them, it sent them off the queue, and now we can see now it's just checking every so often and it's not finding anything ready for processing. So it's just going to keep running and waiting for something to come in. So let's say if I send another request, I caught another Bulbasaur. Let's just execute this a few times. If I go to the logs, we're going to see it's like, oh, we found some more to process. I'm not sure if we're going to be able to see the messages on RabbitMQ, but yeah, we can see that it picked up some. Yeah, and then we can see we have three messages ready for the processor to pick up. And that's what we're going to be doing in the next part is we're going to be working on the processor. All right, so I'll see you there. All right, so welcome to part 2 of this series where we are going to set up the processor. Right now you should have your source set up and it should be checking to see if new requests have come in. As you can see here, the source is trying to find new records to process. For now, I'm just going to put this on, stop this, and we are going to go into this processor source code here, and this is where we're going to be making our changes. Before we start on that, what I want to do just to make things easier, go into the source demo and find the resources application YAML. Let's just copy everything from here and then put it inside of the processor demo. So source main resources, we can delete this and then we can rename this to a YAML. And I'm just going to go ahead and paste it in. So I'm going to remove that. Pokemon processor demo. And the port, we're going to do 9003. The database is going to be named processed Pokemon database. We're going to leave everything the same except for this part we are going to change. I'm going to delete this for now. We'll come back to it later. Comment that out for now. And let's make sure everything looks good. The next thing we need to do is we need to set up this database. So I'm going to copy this process Pokemon DB, go into our Postgres, click on this database, right click on it, create, and we're going to call it process Pokemon DB, owner Postgres. Go ahead and save that. Okay. Now what I want to do is just close the other tab so we just have this one open. And I'm going to minimize this. Let's go into our main Java processor demo application. And I'm going to go ahead and give it a run to make sure we got it set up correctly. All right, so it looks like it started up and we're good to start working. So I'm going to go ahead and stop that. First thing we want to do is create some packages to get us set up. So the first thing is entity for tracking what our table will look like, an event, gateway, repository, and the service. So this is going to be a lot simpler than the source microservice we were working on. Yeah, basically we're gonna start at the gateway and then work our way from there. So let's go ahead and create a new Java class called Pokemon Homing Processor. That configuration, all args constructor, and we're going to do some SLFJ for logging. We're going to be using a service called the Pokemon Homing Service. And I'm going to go ahead and get this class created inside of our service package. Make sure to annotate that with the service. I'm going to go back to the gateway. And basically, this is going to be similar to what we did with the source. And the method we use here, we're going to want to save this method because we're going to be putting it inside of our application YAML inside these bindings here. So create a bean. And then public, we're going to use those functions again from Java util function. And then we're going to get the new Pokemon event and homing Pokemon event. So basically we're going to be transforming it, right? We're going to get a new Pokemon event and then we're going to transform it to a homing Pokemon event that we're going to send off to the consumer. So homing Pokemon process, and we are going to create these here. Let's see, so alt enter, create the class, and we're going to set it up in the event. And go back to the gateway. Let's make another event for the homing Pokemon event. And that's going to also go in the event package. All right. So let's go ahead and just create those events so we have them ready to go. The new Pokemon event is pretty much going to be similar to what we created earlier. We're going to change this to a record. And we're going to have a list of Pokemon details. Pokemon detail list, and we're going to create that Pokemon detail. And it's going to go in the event. This one's basically going to be the same as the Pokemon detail we made in the source one. So let me just go in there. and put it to the side. Just let me confirm we got that. So yeah, it should be, everything should be the same. So I'm just going to copy this, put it in here just to make it easier. And then, yep, we got that. Gotta get a list. And then we are going to, in the homing Pokemon event, this is also going to be a record. And this is going to have, it's almost going to be the same as the other one, but it's going to have a different object. So Pokemon homing status and Pokemon homing status lists. I'm going to create a new class inside of the event package. So Pokemon homing status, and it's basically going to be nearly the same as our Pokemon details. So I'm just going to grab these annotations and post them in here. Basically everything's going to be the same. Oh shoot. One thing I just noticed is that I'm not going to be sending the IDs for both of these, so we'll just delete the ID. So inside of this Pokemon detail, we want to just delete the ID. We don't want to carry that with us. So inside of the source demo, make sure you remove the ID from there. And then Pokemon homing status, we're going to have a new enum. So I'm just going to go public enum homing status daycare or Pokebox. And we're going to add that here. Private homing status, right? So I'll have that set up. And let's see here. Let me just make sure in this Pokemon detail we take out the ID. So it's not the same. So it's the same as the other one. Should be matching. Okay. And then the homing Pokemon. Yep. Everything should be good. I'm going to go ahead and close this out. And make sure it looks good. So these are the events we're going to be processing. Homing status is going to have this new homing status ID and the homing processor. So that looks good. We're also going to be saving it to an entity on our table. So let's just go ahead and create a new entity. And it's going to call Pokemon again. And of course, this one's going to be similar to the entity we created earlier. So I'm going to put this side by side and just reuse some of this stuff just to keep it simple. Table name equals Pokemon processed. You're gonna know it's gonna get kind of repetitive, but yeah, just to keep it simple, just gonna reuse this stuff. This is just for demo purposes, so doesn't matter too much. And we want to remove this processing status, and we want to set a new one. Homing status. All right, so we're going to change the status. So it should look like that. We can close this one. So we got a new homing status. Basically everything carries over from before. And the homing status is going to be based off of the Pokemon homing status right here. Daycare or Pokebox. Okay. And now we need to fill out this processor. Okay, so what we are going to do is turn new Pokemon event function. Close that. And let's see. Set a new homing Pokemon event. And we're going to be using that Pokemon homing service, and we're going to create a method called homing Pokemon process. And we're going to send in the new Pokemon event. All right, let me make sure that looks good. Want to create a new method, so Alt Enter. Create method. We'll come back to this to fill it out. But for now, we're just going to finish this up here. So I'm going to send a log info 1234 publishing Pokemon homing status 3. This is just gonna let us see that the process is working the way we would expect it to. So homing Pokemon event, Pokemon homing status list dot size. Okay. So you'll notice a lot of these events are kind of similar, and you might want to have like a library that you import yourself to just have like a global variables or POJOs. But you know, I'm just making a quick tutorial. Okay, so homing Pokemon event, Pokemon homing status list. Is it empty? If it's empty, then we want to do null. Otherwise, we do homing Pokemon event. Yeah, we're gonna just return a homing Pokemon event. I believe this has got to go here. This has to go here. Okay. So this is the function that we will be using inside of the processor. And basically, we'll get a new Pokemon event, run it through our service, save it into our database, and then convert it to the homing Pokemon event. And the homing Pokemon event is going to be picked up by our consumer to finally drop off the Pokemon into its final destination. So let's go into the service so we can fill out this homing Pokemon process. So the service is going to have a little bit of few things. Let's see here. So first we need a repo. So private Pokemon homing repository. We need to create that. It's an interface, so Alt Enter, create interface, and we're going to set it inside of our repository package. Okay. Pokemon repository extends JPA repository, and we're going to use that Pokemon entity we created, and the identifier is a long. Looks good. We want to annotate this with a repository. Let's make sure there are any other methods. So that should be everything we need for this repository. Let's go back to the service, and we're going to populate this method here. So it's gonna have a lot of stuff in it, but yeah, we're just gonna go through it. So list Pokemon detail list. Let's import that list, and then it's gonna be equal to new Pokemon event that we received from RabbitMQ. We're gonna get the list of details. And then we're gonna do the Pokemon homing status. Pokemon homing status list equals Pokemon detail list dot stream. Stream the list, and we're gonna map it to our homing Pojo that we just created. Okay. That. Alright, so Pokemon homing status equals Pokemon homing status builder dot build. Same as before, bean utils, copy the properties, Pokemon detail, homing status. So we're going to copy everything as before. Log.info. Oh, I forgot to add some args. So we definitely need the all args constructor so we can inject this dependency and then add SLF for J for our logger. Pokemon detail plus Pokemon detail get total. So what we're going to do is we're going to get the Pokemon's total power and decide from there. Like if the total power is less than 400, we're going to send it to the daycare. And if it's over 400, we're going to say we don't need to put it in the daycare. We'll just put it in the Pokemon box. So if Pokemon detail get total is less than 400, like Bulbasaur, we're going to set the homing status to Pokemon homing status daycare. Yep. Otherwise, we're going to set the homing status of the Pokebox. Pokemon homing status dot Pokebox. Okay. This is supposed to be set. All right, that looks good. And then we're going to return the homing status. And we need to set it to a list. Okay, that looks good. Now we're going to create an event. Homing Pokemon event equals new homing Pokemon event, and we're going to set the homing status list. We're going to send that out. But before that, we want to save the Pokemon homing status. Nope, 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 nope. We want to get the list here. We want to save that list. But we're going to return the homing Pokemon event to our processor. So yeah, we're going to use this repository. We're going to create this method here. Okay, so we got a list of Pokemon homing statuses, and we're going to save them to the database. So we got a list of Pokemon list, Pokemon homing status list dot stream map, and we are going to save them. We're going to set the status, and then we're going to save all of them. All right. So we're going to create a new Pokemon entity. Equals new Pokemon. And then use the bean utils again to just copy the properties. So Pokemon homing status, and then we're going to copy it over to the entity. And then Pokemon set the homing status. So Pokemon homing status dot get homing status. dot name. So what this is doing is it's getting the homing status, which is the enum, and we're just getting the name variable of that enum, and then we're going to return it. Okay, and then we also need to set this to list. And then finally, we're just going to log it out that we're saving it in, just so we can just see that for clarity. So saving Pokemon homing status, and then Pokemon homing repository save all. Save that list that we just created where we changed their status. Okay, so that should be everything. What we're going to do next is we're going to actually run this to make sure it works. All right, so first thing we want to do is we want to get the source running. So let's get that going. Let's scooch this to the side so we can see what it's logging. All right, so we got check for new Pokemon request. Also, I almost forgot, before we can do that, we need to set up this application YAML. Yeah, so we need this gateway. We need to grab this homing Pokemon process, and we need to set that up in our cloud bindings. So first thing we want to do is Pokemon in. So this is where we're getting it in from the source. And we destination is the Pokemon processing. So that's the exchange name that we set in the source from earlier. And then the group is the same group we set as before, homing Pokemon. And then we want to send it out. So out to our consumer, and we're going to send it to the destination Pokemon homing. This is also the exchange name. And the group is homing Pokemon. Okay, so that looks good. That should mean we're all good to go. So we got the source running and we have our processor. I'm going to go ahead and get the processor started up to see if it's good or if we have any issues. All right, so let's get this started up. Okay, so, oh no, now we got a problem here. So you see this often, B cannot be cast to Pokemon processor event, new Pokemon event. Yeah, it looks like it tried to pick up some messages. I'm gonna, I think it's because we had the old messages. I'm gonna stop these. I'm gonna stop these and clear out our queue real quick because I have the old ID. So as you can see here, if we went to the queue where it's processing, we saw that there's this ID here, but I deleted that earlier and it no longer exists. And we don't want that, so let me just make sure the queues are empty and we don't have anything going for us right now. Let's just check here. Pokemon processing. Okay. I'm just going to go ahead and restart again and see if that issue persists. All right, let's go ahead and start up the source again. Okay, nothing to process. And then I want to go to the processor application. Let's make sure that error doesn't pop up. Okay. All right, so what we're gonna do here is we're gonna test it out to see if it works. Let's go back to our endpoint here, and we got this Bulbasaur. So I'm gonna go ahead and execute this. We got this Pokemon reference number, and then let's check our logs to see if there's any. Okay, so it looks like everything was successful. It picked up the one Pokemon request, and then the processor, it also found that Pokemon. So we found the Pokemon total was 318, saving Pokemon homing status. And we published one status. So let's look at the database here. What was the table name? The table, process Pokemon DB, process Pokemon DB. I'm going to go to the table and find the table that we created, Pokemon process. Do a select on this. Okay, now we're gonna just run this quick select on this, see what we got. Yeah, so looks like it was successful. We can see that we picked up this Bulbasaur, and since its power was 318, we're sending it to the daycare. So in the final part of the consumer, we're going to be placing the Pokemon in the daycare or the box. What I'm going to do is try and do another test to see if we can send something to the Pokebox. So I'm just going to copy the properties from this CSV for, let's say, just Ivysaur. Let's put an Ivysaur in our data. So copy this, name Ivysaur, grass, poison. The total is 405, HP of 60, attack of 62. You can pretty much just put whatever you want here. The main part we're testing is just like the total. Whatever else we have here doesn't really matter too much, but I'm just going to fill it out. So defense of 63, special attack of 80, special defense is also 80, and then also the speed is 60. Generation 1, it's not legendary. So let's go ahead and run that process. We got a reference number. And then let's look at the logs here. We're checking, it's looking to see if anything came through. And then it looks like we got another record process. That's for the Ivysaur. And then if we look at our processor, we can see that it found another Pokemon and the power was 405. So we set up another homing status for it. If I go back to Postgres, run this select statement again, we're going to see we got the Ivysaur and it was sent to the Pokebox. So far, so good. Okay, so now that we got the source and processor working correctly, we're going to do our final part, which is the consumer, and that's where we're actually going to be placing the Pokemon inside of the daycare or the Pokebox. So I will see you there. Welcome to the final section for this mini series on Spring Cloud Stream. We set up the Pokemon source demo and the Pokemon processor. Now we're going to do the consumer, which is going to consume data from the processor and finally place our Pokemon in either the daycare or inside of the Pokebox. So before we get started, there are a few things we need to set up. What I'd recommend is go into the processor demo microservice and select the application YAML. And then let's just copy these properties over into our consumer demo. So go to Pokemon consumer demo, go to source, main, resources, and then go to the application properties. Let's delete the static and templates because we don't really need it. And then rename this to YAML. And then we can go ahead and post our changes in here. Set the Spring application to Pokemon consumer demo, and then the server port, we're going to do 9004. Everything else should be the same except for these bindings. Let's delete these bindings and we'll get back to them later after we get the source code set up. So once you have this, we are ready to go. Also, you will need to change this database table name, and we're going to change it to home underscore Pokemon, and copy that. Go into our Postgres. Let's name it Pokemon Home DB. I'm going to save that, and then go into Postgres, go to our databases. Let's create a new database. Pokemon Home DB, owner Postgres. Let's go ahead and save that. That looks good. Save all. And then let's just run a quick startup of this application. Make sure we are good to go. All right, everything looks good. We're on port 9004. One other thing you should make sure is you have these libraries set up for the Open API and then the Apache Common. And we set them in here. Should be similar to how we set up the source one. All right, so everything looks good. I'm going to go ahead and create a few packages. So the first package is going to be the controller. Next package we are going to have as our entity, and then we're doing the event. Another package for the gateway, repository, and the final package, which is the service. So this is going to be pretty much the same as our others. We're going to start at the gateway. And before we get started, let's just close all of our other tabs. So close all tabs. And we're going to start at the gateway here. I'm going to create a new gateway, which is the Pokemon homing event listener. And this is where it's going to pick up our RabbitMQ messages. And then based off what we get from that queue, we're going to place their Pokemon in their destined database tables. So let's go ahead and add these annotations and then get this event listener set up. So first thing we need is a service, so Pokemon homing service. And I'm just going to go ahead and create that service real quick. So create class. I'm going to put it in the service package. And let's just annotate this as a service. We're going to go back to the event listener, and we're going to set up the bean for our consumer. All right, so public consumer, and we're using the Java util function. We're going to do a homing Pokemon event. So we're going to receive a homing Pokemon event that we created in the processor. Pokemon homing arrangements. And we're going to create this Pojo here, this event Pojo. So create class, and we're going to put it in the event package. We will deal with that a little later. Basically, let's just finish up this consumer real quick. So Pokemon homing event. And actually, let's get that event set up. So we are going to have another object inside of here called Pokemon homing status. Let me see if that's similar to what we have here. Pokemon homing status and homing Pokemon event. So they're pretty much going to be the same as the ones we created earlier. This homing Pokemon event is going to be a record and not a class. And we are going to list out Pokemon homing status. Pokemon homing status list. Okay. And basically what we can do is just make sure we have it the same as what we set up in the processor. Okay, so that looks good. And then the Pokemon homing status, open to the right, pop that in here. Should be the same. Let me just double check. Yeah, so everything in here should be the same as what we did in the processor. So grab that, paste that in here. Getter, setter, builder, no args, and all args constructor. We got the homing status, reference ID, which we're going to be carrying throughout all of these events. Okay, so that looks good. We got our events, and if you guys need a reference point, I'm going to be putting this in my GitHub and posting it in the description. So if you need something to reference in the future, you'll be able to look at that source code. So log info received Pokemon. And then we're going to do homing Pokemon event dot Pokemon homing status list size. So we're going to see how many did we receive during that event. And then we're going to use the homing service to determine Pokemon arrangement. And we're going to do homing Pokemon event dot Pokemon homing status list. Yes, that looks good. So now we are going to update the service to handle determining where our Pokemon is going to go. So I'm going to go ahead and create that method inside of our service. And then let's go ahead and hop into the service so we can get it set up. This is probably going to take a little bit of time. First thing we want to do is add the all args constructor so we can inject our dependencies, slf4j for logging. And we're going to have two different repositories. We're going to have the, for two different tables. So we're going to have the Pokemon box repository. And we're going to also have the Pokemon daycare repository. All right. So let's create those repositories. And before we actually get those repositories set up, we want to create the entities that those repositories are going to act from and off of. So the first one's going to be Pokemon box. And the second one is going to be Pokemon daycare. Now this isn't going to be like exactly like how they do it in the game, but you know, we're just doing this for demo purposes so we can understand Spring Cloud Stream. All right, so getter, setter, entity, and the table name was Pokemon box. Yep. And let's do the same thing for the daycare. Daycare. Okay, so Pokemon box. Basically, we're just going to use the same details that we created from our other entities. So we can just copy those other entities we created before. I'm going to go to the Pokemon processor demo and then open it to the right. And we're just going to copy the same details. The only thing that's going to be different is we're not going to need the homing status because we finally placed the Pokemon in their right location. And then this Pokemon box is going to be the same as Pokemon daycare. Yeah, pretty much just keep it the same. Just keep it easy, keep it simple. We got a reference ID that we're going to be using in our controllers later to check the status of where that Pokemon went. And yeah, now we have our entity set up, so now we can go back to our service and get these repositories set up. Okay. All right, so let's get this repository created. I'm going to do an Alt-Enter here, create the class in our repository. Click OK. Actually, this is supposed to be interface. And I'll close this. Extends JPA repository. And we're going to be representing the Pokemon in the Pokemon box here. And this is going to be a repository. We want to find our Pokemon by the reference ID. So I'm gonna create a custom method for that. So find by reference ID string reference ID. All right, that looks good. Just gonna copy this because we will use it for the daycare as well. So just to make sure I'm consistent, I'm gonna go back to the service, Alt-Enter, create interface, and we're gonna set that in the repository. Click OK. Oh, day car. Yeah, we need to rename that. So refactor, rename, add a E, enter. Yes. Daycare repository. Okay, that looks good. And then extends JPA repository, Pokemon daycare, and we're tracking them by long identifiers. And then we want to return from the Pokemon daycare, find by reference ID. All right, so our repository is all set up. Let's get the homing service set up. So we are going to get this done. So it looks like I got another typo here. I'm going to refactor that. Rename, arrange. Oops. Arrangement. That's coming from our gateway, so yeah. All right. Now we got to determine where we are placing our Pokemon that we receive from the processor. So Pokemon homing statuses. Don't really like this, so I'm just going to rename this to something else. Let's see. Status list. This list up for each Pokemon we receive. We will be doing the following. If Pokemon.getHomingStatus, no, get homing status equals Pokemon status daycare. We're going to log this out. Info for sending Pokemon to the daycare. Then Pokemon get name. And then create an entity, Pokemon daycare, new Pokemon equals new Pokemon daycare. And then we're doing a bean utils copy properties, Pokemon, new Pokemon. So we're receiving the Pokemon from the processor, and then we're going to set it to copy it to the new Pokemon here. And then the Pokemon daycare repository, we're going to go ahead and just save that new Pokemon into the database, right? So now it's found its home inside of the daycare. And let's go ahead and log that out. Saved Pokemon to the daycare, period. And then Pokemon.getName. So we know which one we saved. Otherwise, we are going to do something else. Also, let's add a semicolon here. Basically the same thing, but we're going to change the repository. So I'm just going to grab this and paste it in. We're going to change something. So instead of Pokemon daycare, we're doing Pokemon box, a new Pokemon box. Bean utils, we're going to copy them over. Instead of the Pokemon daycare repository, we're going to do the Pokemon box repository. And then instead of daycare, we're going to call it Pokebox. Pokebox here. All right. So theoretically, we should be good here. That should get us everything set up. There are some final things we need to do. So we need to go into the gateway here, and we want to save this method, and then go into our application properties so we can set up the cloud stream bindings. So inside the bindings, we're going to paste that method, and we're going to say incoming here from the destination Pokemon homing. And this is obviously the exchange name. And then the group is the same as before, homing Pokemon. And then consumer max attempts of 1. I'm going to add a little bit more bindings. So let's see, rabbit bindings, consumer, auto bind, dead letter Q, true. All right, that should get us set up and good to go. Let's see, save all. This Pokemon homing should be the same thing we had in the processor. So if I open this to the side, we'll see that when the processor is sending something out, it's sending it to the Pokemon homing destination. And that's the destination where we're going to be picking it up in the consumer. All right, so technically we should be done here. And yeah, we can run this, but before we do that, what I want to do is actually set up the controller so we can just view from a customer's perspective. If they have the reference ID, they should be able to see the status of their Pokemon. It's kind of like when you buy something off Amazon and you get the tracking number, you can track the status of where that package is currently. So we're going to create a new controller here called Pokemon Home Controller. And we're going to give it all of the annotations we need. So REST controller, SLF for J, all args constructor, request mapping. Request mapping, we want to do Poke Home, and the tag we'll do as Pokemon Home Controller. Alt Enter. Okay, and now we want to create the controller. All right, so this is going to be the last steps we're going to need to do, and then we can test it out to make sure everything's working as expected. So let's go ahead and set up this REST endpoint. So I'm going to add some Swagger annotations. So summary, locate, Pokemon home, and then API responses with the S. Set the value of our API responses. So we're going to have 2 of them. And yeah, let's see. So the first one is response code 500, description, internal server error. And the other one, response code of 200, description. Okay, let's just go with that. And then we're going to do a git mapping of locate by reference ID. And now we'll go ahead and set up the method. So response entity string Pokemon homing status. All right. Let's see here. Let's just go ahead and add the arguments we need. So at parameter Swagger, add a description, Pokemon, homing, reference ID, acquired of true, and the actual parameter string reference ID. So when we kick off the process from our source, it's going to create a reference ID. This is kind of like a tracking number that we can use to track our Pokemon and make sure it got home to the right location. If it got stuck somewhere, we can track in the database tables possibly where our Pokemon got lost, right? All right, so let's check and do some string utils to validate that our reference ID is not empty. If it is empty, we obviously gotta have to send a bad request. Bad request, build, and then string status equals Pokemon homing service. Oh, I forgot to add our service in. Forgot to inject that in there. So private Pokemon homing service. And here we are going to find our Pokemon. Pokemon homing service. Find Pokemon location by the reference ID. So obviously, might want to normalize our tables. There could be an easier way we could to find our Pokemon, but yeah, I'm just going to do this setup real quick and just so we can just get a result. Status of, nope, not that. HTTP status. Okay. Body, then set the status. All right, so now we need to go ahead and find our Pokemon's location. So I'm going to go into the service and we are going to run some quick logic to locate where our Pokemon ended up at. Log info searching for Pokemon location using reference ID. All right, that looks good. I guess we will just query both the repositories. So Pokemon daycare equals Pokemon daycare repository, find by reference ID, and then Pokemon box repository, find by reference ID. And then let's do some quick if else. So if Pokemon daycare does not equal null, then return your Pokemon plus Pokemon daycare dot get name is at the daycare. Okay. Else, if Pokemon box does not equal null, we'll return the same kind of deal here. So return your Pokemon in the Pokebox is in your Pokebox. And then otherwise, if we don't get anything, return no Pokemon found with the provided reference ID. This means the process errored out somewhere and Pokemon got stuck in processing. All right. Anyways, looks like we're all done here. Next thing we're going to do is test this out and make sure everything is working as expected. First thing I want to do is get our source up and running. So I'm just going to go, since I have everything up and running, we should be able to see them here. So I'm going to go to the source here and I'm going to boot that up. Okay. Make sure everything starts up. Okay, so it's looking for Pokemon to process. We're going to start the processor application, get that booted up as well. All right. Everything looks good. And then for the final piece, the consumer, let's go ahead and get that running. We'll see if we get any errors here. Let's check. Just make sure we're good. Pokemon DB. Okay, so it looks like right as we booted up, there was some Pokemon waiting in queue to be homed, and received one. We sent it to the daycare, and we got Ivysaur, and we also sent him to the Pokebox. So if we look inside of our Postgres, and if I go find that table, home Pokemon DB, and then we want to find home Pokemon DB, we want to find the table. So we got the Pokebox, and let's do a select script here. Run this, and we can see Ivysaur got placed in the Pokebox. And if I go to the daycare, run this, we can see Bulbasaur got placed inside of the daycare. What I'm going to do is I'm going to run one more query and try and test it all the way through. And we're also going to check out the consumer as well. So I'm going to go localhost 9004, I believe, and then go to the Swagger UI.html. Okay, locate by reference ID here. Let's wait for that. So let's send a I guess we can send maybe like a Pidgey to the through our system and see where it ends up. So Pidgey is a normal kind of Pokemon. So let's just grab that. And he is also flying. His total power is 215. HP is 40. Pidgey's kind of weak. Attack 4. Okay, 40, 45, 40. 45, 40, 35, 35, 56. 35, 35, 56. Generation 1, legendary false. So we'll send Pidgey through. Another consumer you can also make is just like a consumer that could probably read off the CSV data and then take that CSV data and post it into a database. And that way, like, let's say if we got new Pokemon coming in, they create new Pokemon, we can just create another CSV and then just stream that data through. But for this demo purposes, we're just going to do a REST endpoint. So I'm going to go ahead and execute that. We got the Pokemon captured and we're sending it off either to the Pokebox or daycare. We got this reference number here. So let's just check the logs. In the consumer, we got another Pokemon received and we sent it to the daycare. We can also confirm that inside of Swagger. So if I try this out and post the reference ID that I got, let's execute this. We can see we got a response that says your Pokemon Pidgey is at the daycare. All right, so it looks like everything was created successfully. And yeah, that's basically how you can use Spring Cloud Stream to stream your data, which is pretty nice. Basically, let's say with the CSV example, if Pokemon decide to come out with new Pokemon, we could just place our CSV in a certain location and then our source should be able to just pick it up and just send it through and process it, right? But also with like the trading card example, what if we had people sending us cards they wanted to get rid of, and then we could use our source to consume it and then processor to determine like, do we want to send this for PSA grading? Is this a rare card? Or do we want to just put it in our e-commerce store to sell because it's not the best condition, not what we're really looking for? Anyways, that's the demo. If you like, please like this video. And also, I might do another demo on setting up Spring Cloud Data Flow. So with Spring Cloud Data Flow, we should be able to create jars for our the streaming service we just created, and we can plug it into Spring Cloud Data Flow. Anyways, yeah, I hope you guys have a nice day. I'll talk to you later. Bye.